This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Okay, so I trust Tom warned you that somebody else would be taking his lecture today. Well, that's me. I'm Peter Jachty. So the topic for today is immutable objects. So objects are covered over a couple of weeks. And this week we're covering sort of the first half of it. Yep. I don't understand what's... Okay. Okay, so Java is an object-oriented programming language, and the sort of central idea of object-oriented programming is, not surprisingly, objects. So essentially an object is a thing that stores some data. And it can store various amounts of data depending on its design. Each object is an instance of some class. So when you talk about objects, you have to also think about classes. So the central idea here is that a class collects together two things, sort of the two things that programming is built on. One is code and the other is data. The idea of a class is to pull the two of these things together into one construct that lets you talk about both at the same time. So an object is meant to represent something. It's meant to represent something, a thing, and that can be a thing in the real world, like a student or a book or an airplane. It could also represent a more abstract kind of concept that still reflects the real world, but not a physical thing you could touch, such as a university subject. You can't touch this subject, or a library loan, or a flight on an airplane. And an object can also represent a still more abstract thing that doesn't really represent anything you could talk about directly, but is really just used to construct the program, used to implement the parts of your programs, something like a list or a string. Those don't reflect necessarily anything in the real world, physical or anything even figurative in the real world. They just are a mechanism that you use to implement something in your program. Okay, so in order to, once you have a class, in order to build an instance of that or instantiate that, Java has a separate construct, a special construct called new. So new is a keyword. You can't use it as a variable name or a method name or anything like that. It's a special word. And so the way we construct an object in Java is we say new, and then specify a class name, and then an open paren and some arguments, and a number of arguments, and a closed paren. And of course the semicolon at the end. So new is an expression. You can use it anywhere you can use an expression, and what it does is create a fresh object of the named class, of, in this case, class. And the most common way, the typical way you'd use this is you declare a variable where class is the type of the variable. So class var, some variable name, equals, and then new class and all of that stuff, and a semicolon. So that's your typical use. So up until now, you've seen this when we said something like scanner keyboard equals new scanner system.in. So there's it only takes one parameter, and in fact there could be no parameters at all. And what are the correct number and types of parameters to supply is determined by the class. In fact, by the constructor, which we'll talk about a little later. There's sort of special objects that Java will create for you automatically, such as this one. If you say, quote, constant string, that's an object, and you didn't have to create it. Java just does that for you. So that's a special case. Usually, when you want an object, you have to actually create it. Okay, so once you have an object, there's two different things you can do to it. One is you can send it a message, and the other is you can send a message to some other object and pass that object on as one of the arguments. So you can say, if object is your object, you can say object.message whatever, 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 and send a message to that object. And then, of course, these expressions can be any valid Java expression, and an object is a valid Java expression. So you could pass an object there. So when we said system.out.println hello world, there's two objects there. One of them is system.out. Okay, it's sort of a compound name, but there's a package system, and that package contains an object called out. So system.out is an object, and we're sending it a message, and the message we're sending it is println hello world. So system.out is an object that you can send messages to, and it will perform input-output. In particular, it will send it to the console. And then this object, of course, we didn't need to explicitly create. Java built it for us, but it is an object. Okay, and so you might wonder, how did we know we could say println as a message to system.out, or in general, if you have an object, how do you know what messages you can send it? That's determined by the class. So the class tells you what you can do to an object. Java also has a special thing. I'm not going to call it an object because it is not an object. But you can use it wherever you could use an object. But if you do, you may crash the program. So we have to be a bit careful of this guy, but it's called null. And so null is a special thing that you can act as if it's an object, but it's not. You can pass it wherever you could pass an object, but you can't send a message to it. Basically, the only thing you can do with null is check to see if it's null. It's the only useful operation you have on it. Well, and aside from passing it to other things. Okay, so for example, if we say string s equals something, whatever that is, I don't know, then if we want to know whether or not we can print it, we have to say, if S not equal null, then we print it out. Okay, so if we leave this out, and this dot, dot, dot is just null, semicolon, or we send some message to something that's supposed to return a string, and it returns null, which is always allowed. It could do that. If we do that, and we forget to say if S not equal null, then this is going to crash. We'll have a runtime exception. In fact, what we'll have is a null pointer exception. Okay, any questions on that before I go on? Okay, so one of the key functions, one of the key operations that a software developer does is modeling. This is what happens when somebody has a real-world problem to solve and you go off to try to solve it. What happens is the real world is infinitely complex. This is something you've been doing since you started programming. In fact, it's something that we really all do naturally from the time we're this big. We model. We approximate. We abstract the real world into a nice, simple world that we can wrap our heads around. And so this is a really important concept to wrap your head around, is that this is what you're doing all the time when you program. You're trying to understand things, you're trying to simplify things so that you can implement them. So what we do when we design software is we try to understand the problem we're solving in terms of what are the things and what are the things that happen to those things. What's the data and what's the code? What are the objects and what are the operations? And object-oriented programming is designed essentially to address that problem. And that's why by the way, why a class contains both code and data. That's why we've done that, because that's everything. And so now we can model it, or now we can do a better job of modeling it. So when you're designing a piece of software, you have to think in terms of what are the things we care about in this project, and what are the operations that can happen to those things. And almost as important is what are the things we're going to ignore. There's so much stuff. There's infinite complexity in real-world processes, and we have to ignore most of it. We have to ignore an infinite amount of it. So basically, the rule of thumb is if you can skip over it, do. If you can simplify it, do. Keep it as simple as possible. And then sometimes, of course, as Einstein once said, everything should be made as simple as possible, but not simpler. So you have to know where you have to give up simplicity in order to achieve your aims. So let's take a concrete example. Suppose there's some kind of real world disaster, flood, hurricanes, earthquakes. These things happen. And when they happen, all of our systems get disrupted and people get separated. And so the real world problem is, you've got parents over here happen to stay together. Kids happen to be at a school at the time, and they get pulled out of school when the earthquake hits, and they get sent off to some other place, and then they get sent to some other place. And at the time, the most important thing is to keep people safe, and less important is to keep track of who is who and where they are. But now parents are, beside themselves. Kids are panicking. We're trying to get them back together. So we've got a lot of people lost. How do we connect them back together? So that's the problem we're trying to solve. So the idea here for this particular project is we want some agency, presumably a government agency, but I suppose it could be a non-governmental organization, comes in and they sort of make themselves available, and we're assuming they have some communication ability, maybe radio or something that's robust. And they go to places, to shelters where people are congregating, and people just sort of march up and say, hey, I'm George, I'm missing my son Frank, whatever. And then somewhere else, maybe in a school gymnasium somewhere, somebody else is walking around and, so who are you? Oh, I'm Frank. I'm missing my parents. What are their names? Mom and Dad? Okay. So we're going to try to get them back together. All right. So that's the problem we're trying to solve. So now let's model it. What are the entities that we need to consider? So what do you think? What entities do we need in this? Sorry? Person. Yeah, absolutely. That's sort of the first thing. We have different people. Okay? What else? We're trying to get them back together. So what else do we need?
The name of the people they're looking for.
That's also a person.
Yeah, maybe address them.
An address? Yeah, okay. So more generally speaking, a location, right? So, I mean, it may be a street address, but it might just be, in a football field somewhere. People are in places. Okay, so we need people, we need locations. There's another thing that's a little more subtle. So, the system knows that George is looking for Frank, and the system later discovers here's Frank, and Frank is in this school gymnasium, but the floodwaters rose, and everybody in the school gymnasium was moved on to some other school on higher ground or something like that. So when they finally get to the school gymnasium to pick up George, did I get that right? No, Frank. He's not there. So one thing they need to understand is when a person was in a location. So we have the idea of the concept of a person, we have the concept of a location, and we also need to have the concept of a time when that person was in that location. So we can say, oh, well, yeah, so he was here 8 hours ago, but now he's not here. Okay. It would be nice to have some idea of where everybody from here went when they were moved on, but you might not have that. So let's start off, let's keep it simple. Those are three concepts that we're probably going to need. So now we have sort of more modeling decisions to make. So we have the concept of a person. The question is, what is a person? In particular, when we've identified a class, a kind of object, kind of entity maybe, because we don't like to call a person an object, do we? But an entity. So we have a concept of some kind of entity like a person. what we want to know is, what do we need to know about a person? And then what are the things we can do with a person? So somebody was saying name. That's a sensible enough thing. But what's a name?
A string.
Yeah, a name could just be a string. Or, so, I mean, how many online forms have you ever filled out? When does it just say name? They almost always want to know, what's your first name? What's your last name? What's your middle name? What's your title? What's their everything? And so they make it more complicated. So why do they do that?
They want to make it unique for everyone.
They want to make it unique. That's probably not why. A name is never going to be guaranteed to be unique. So, you know, there must be a million John Smiths or whatever. So, so the name wouldn't be unique. Why do some of these companies that want your name force you to break it up into separate pieces? Exactly. Right? Okay, so I don't know if you heard that. So the point is, if they break it up into a first name and a last name, then they can call you Mr. something or Ms. something, so they want the title. Or when they address the body of the email, maybe they say, you know, just call you by your first name. So they want to know those separate pieces. But is that appropriate in this context for this application? Maybe not. You just want to know somebody's name. And the problem is, you know, when you talk to Frank and he's 4 years old, he might not know his surname. He might just know his name is Frankie. So essentially, there's a trade-off between flexibility and sort of usability or ability to use that data for a particular purpose. So the key thing is to understand your purpose and represent your data in a way that's appropriate to your purpose. In this case, splitting it up into lots of separate pieces might be counterproductive. So, as I say, go with the simplest design that could possibly work. That's sort of a general piece of advice when you're developing a piece of software. Go with the simplest design that could possibly work. Okay, so now we've talked about the data. What are the operations on these data? In the case of a person, we've got a name. Well, I suppose the first thing is we want to be able to get a person's name. But the other thing we want to be able to do with a person is find out who is looking for them, basically, right? So George says he's looking for Frank. And, okay, so now here's a point. George is looking for Frank. Frank is 4 years old, doesn't even know his own surname. Knowing what clothing he was wearing or a physical description would be quite valuable. In that case, that's quite useful. So maybe we need to store some more information about that. And in that case, another operation we might want to have on a person is to get a description. Okay, so what else? The other thing is when we're comparing, a person appears and says, my name is George, or sorry, my name is Frankie, and another person appears and says, my name is George, I'm looking for Frank. We need a way to say, well, Frank is the same as Frankie. Or at least to guess that Frank might be the same as Frankie, and then that needs further investigation. And then maybe we take a picture of Frankie and show it to George, and George says, yes, that's my son. So in that case, a person might need to have a picture recorded for him as well. So as we go along, we fill in or sort of add more to what we need to store. And this is all part of the modeling process. Okay. All right. So any questions on modeling? All right. All right. So once we've done the modeling, or at least done a first cut at the modeling, we can start designing the system. And typically what we will do is for most of these entities that we've picked in the modeling process is we'll say, okay, that'll be a class, that'll be a class. So we'll have a class for a person, we'll have a class for a location, we'll have a class for a date and time, or a point in time. So a class is a type in Haskell. I'm probably going to do that a few times. In Java, a class is a type. Just as int and float and double and so forth are types, so is a class. Each instance of that class is an object, and that object has a value for every instance variable, which is to say for each datum that class holds. So a class has instance variables and it has methods. And the instance variables are the data and the methods are the code. Okay, and then every instance of a class has the same set of messages that you can send it, the same set of methods. And then each method gives you one operation you can perform on that object. Okay, so to declare an instance variable, it's similar to declaring a local variable in your methods. Essentially, you give it the type and the name. But I'm going to say one more thing, something that you can't do for a local variable. You also say private at the front of it. Now, you don't strictly have to do that. But I'm putting it in here not as an optional thing, but as a mandatory thing. Not because Java makes you do it, but because good practice makes you do it. You should always make your instance variables private. I'll come to why a little later. So after you've, sort of inside the class declaration, you say something like private type name, and that declares an instance variable of that type. And that type can be a primitive type, like an int or whatever, or it can be a class type. So think of it as being like a class variable declaration, only we don't say static. Okay, so by default, if you don't say static, by default, it's an instance variable. All right, so last time you saw static variables. And the difference is that a static variable is sort of common to all objects in a class. There's only one of them when the program is running. You have a static variable foo, there's only one foo in the whole program. If there's an instance variable foo, then every object has its own foo. Okay, so for example, we might say, so here I've actually broken the person down into a person's name down into first name or given name and family name. So we would say public class person, open curly brace, and now we give the methods and the instance variables, or the methods and the variables, because we can also have class variables. So public class person, we'll say private string family name, private string given name. So every person now has a family name and a given name. Okay, so as I said before, private, Java doesn't force you to say private, but good practice does. Essentially, if you read any of the programming blogs or anything, everybody will tell you this. It's pretty widely agreed. You should always make it private, which kind of raises the question of why that's not the default. Why do you have to say private to make it private? But we'll leave that aside. It was a design decision made, 25 years ago or something, and maybe a mistaken one. Anyway, so it's not private by default, but you should say private. The problem is if you don't make it private, essentially you're giving it away for free to everybody. You're giving complete access to it to everybody. And one of the key design concepts of a class is that a class is responsible for the values of its instance variables. A class has to control what's possible on these instance variables. If you make it private, you've lost all control. If you make it public. If you don't say private, you've lost all control. And anybody who gets a hold of your object can do anything to those instance variables. On the other hand, if you make it private, that means somebody, some object, some code, some method that gets a hold of one instance of this object can't access its instance variables. It can't even read them. So it forces you to take control. Now, what that means is you make it private, you don't have to give access to anything, to any methods, to any other code. Now you have complete control, and you get to make the choice. Okay, so it's up to you to, as the developer of a class, it's up to you to give values to those instance variables and to control them. So they will get default values if you don't specify what values to give them. It's best not to even think of it that way. Java will do that for you, but it's best to just always assign them yourself. That has good documentation value. Okay, so instance variables. Okay, so we've got two different kinds of variables now. Well, actually three if you count class variables. So we have class variables, we have instance variables, and we have local variables. And they all look the same. They're all just names. So how do we know which one we're referring to? Well, the first rule is you can't have both an instance variable and a class variable in the same class that have the same name. So that confusion is not possible. The Java compiler just won't let you do that. If you declare it, you either make it static or you don't, in which case it's an instance variable. So you don't have to worry about that problem, but there is still the problem of you've got the same name. How do you know whether it's a local variable or an instance variable? Or how do you know whether it's a class variable or a local variable? So there's an important difference between all three of these kinds. So remember, a static variable lives as long as the program is running, and it just stays the same until somebody changes it. And if you make it final, if it's a constant, then it never changes. But it lives throughout the length of the execution of the whole program. A instance variable is stored in the object, and it lives as long as the object lives. When the object goes away, it gets garbage collected, it's gone. its lifetime has ended. And finally, a local variable lives as long as the method it's in, or even the narrower scope. You can declare a local variable inside, say, one arm of an if-then-else or something like that. Then it only lives as long as that piece of code lives. Basically, it lives up until the closed curly brace that matches the open curly brace that was before you declared it. Okay, so in terms of lifetime, it's static, and then instance variable, and then local variable is the shortest lifetime. But all of these have to be initialized. You have to set them at some point. So a static variable, you're typically going to assign within the class at the top level. The typical thing is it's a constant, and you initialize it at the moment you declare it, and then it just stays forever, or until the program exits. An instance variable, we'll talk about how you initialize it momentarily when we talk about constructors. And finally, a local variable you initialize typically at the moment you declare it in the body of the code. Okay. Right, and then, so if you have two variables with the same name and one's an instance variable or a static variable, a class variable, and the other one is a local variable, the local variable wins. If you refer to it just by name, you get the local variable. Okay, so in order to declare an instance variable, we declare it, instance methods. Yeah, I'm not reading carefully. So the way we declare instance methods, or typically just called methods, is basically it just looks like a class method. It looks like the main methods you've been writing, but it lives at the top level of a class. So you have some class declaration with an open curly brace, and then at that level, you declare a method that looks like this. So viz is the visibility. We'll come back to that. Type is the return type of the method. And if the method doesn't return anything, we just say void. And name is the name of the method, and then we have pairs of type and name for the parameters to the method. So it looks just like a class method that you saw last week, except we just don't say static. So, similarly to the instance variables. So viz, for now, we'll just say viz can be either public or private. There's actually a couple more choices, but you'll get to them later. For now, let's just say public or private. And private means the same thing for methods that it does for instance variables. It means nobody outside of this class can use this method. So you can use it inside the class. Other methods can use that method, but other classes outside of this one can't call that method directly. So this declaration says we've declared an instance method called name. It's going to return type, and it has arguments of type 1, type 2, type however many arguments we declare. So here's an example. Here's our class person, and it has a family name and a given name. And then let's have a method called get full name. So notice open paren, close paren. We don't need to supply anything to get somebody's first name. We just ask the object, give me the first name. Sorry, full name. So give me the full name. And what that's going to do is it'll take the family name and a comma space and the given name. So we'll put it in that order. And that's what it returns, and that's all we'll say about this class. Notice that we've made it public. So the idea is if you get a hold of a person object, you ought to be able to get their full name. It's a reasonable thing to ask. And so that's how we can do it. Yeah?
Sorry, I'm still a little confused about this code. So public string get full name, right?
Yep.
But what's the difference if I say public static get full name?
Right. So public static string get full name. Yeah. Yeah. So we need the return type. So yeah. Okay. So if we said static in here, then what that means is we're asking for the full name, not of a particular person, but of people in general. In other words, there is no person you're asking this of. You're just asking the program, what is the full name? It doesn't make any sense, right? If you don't have a person, you can't ask for a person's full name.
Like if I remain any other code, does adding one word like static, is that extracting the code from the main tools, like family name plus given name? I mean, the return value will be the same, right? In this case.
If you say static, no, that's not true. See, the thing is, if you say static, then because these didn't say static, they live in an object. If you don't have that object, if you don't have an object, you don't have a family name and a given name. Now, we could have made these static as well. And what that would mean is, when we have the concept of person in a program, there is only one person. There can only ever be one person. If we set the person's full name, or first name, let's say, then we have changed the first name for everything. So we don't have separate people, we just have one person. So that's essentially the idea of static, is there's only one of these things. Whereas if we don't say static, then it's an instance thing, then there's one for each instance. And we can have many instances. If it's static, there's only one instance. There's no instances.
Sorry, maybe I just asked too much questions. But like,
Yep.
in this way, can I understanding if I use static, like another understanding that another language like Python, and I'm understanding this as a very simple variable, but if you're using instant variable, then that will be goes to dictionary where it stores a lot of
Okay. Okay, that's too much detail. That's not the way it works in Java anyway. It's a different thing. So yeah, let's sort of let that go and move on. But the key concept is, if you say static, then it's global to the whole program. There aren't separate objects. If you don't say static, then by default it's an instance thing, and then there's many separate ones. And that's what we want here. So when we can have lots of different people, and that's the point of the whole project here, is to have multiple people. So we don't want it to be static because that would mean there's only one. Okay. So has Tom been doing the quick poll thing? So do you all have internet-enabled devices, and you've been going through this? Okay. So hang on. I need to get set up. So my quick poll address is different than his. So you want to go to qp.unimelb.org. edu.au/Shakti, and that's SCH. Is everybody ready? No, I don't have a whiteboard. I can't write it. Yeah, it's SCHACHTE. So just put that in. So that's how you spell it. I hope everybody can see that. Okay, new poll. All right, so now I will put this thing back up. Okay, so the question is, what will this print? So we have a class called Quick Poll 0501. We'll have a private instance variable x equal 1 and y equal 2, and we'll have a public method m, which takes one parameter, int y, and it returns x plus y. Okay, and then our main method, well, let's ignore the command line arguments because we're not going to use them. And now we'll say new, and don't worry about this part too much. We haven't talked about constructors and so forth, but this just creates ob, which is an instance of this class. And now I'm going to say ob.m of 3 and print that out. So what is this method going to do when we pass it 3 as input? All right. Is everybody ready? Shall we go on, or you want another minute? Think it through? All right. Let's see what people have said. Okay, so I'm getting a lot of answers for B and a few answers for D and even fewer for E. Okay, so let's see what the answer is. The answer is indeed B. Okay, so most of you have got it. The people who didn't get it mostly picked D and E. So I put those distractors, that's what they're called, the wrong answers. I put them in there because there's a reasonable guess that would be the case. Why can't M access X? So here's M. It doesn't have a parameter called Y. Didn't declare any local variables called X. It didn't declare a parameter called X. It doesn't have any local variables called X, and it still uses X. Well, the X it's using is this one. X is 1. So inside a method, you can read the instance variables of that class. And by the way, you can also read the static variables from that class. So if I said private static int x equal 1, y equals 2, that would also have worked. But that's not what I wanted to do in this case. Yes, method M can access X, and this is the one it gets. For question or answer E, no, there aren't two different Y's. I mean, yeah, well, no, sorry. There are two different Y's, but you only get one of them. And you get the one, if there's a local variable and then either a class or an instance variable, you get the local variable. So this Y always is going to have to refer to this. And this Y is just a red herring. It's never used in this whole program. You could just ignore it and the program would behave the same. I could delete it and the program would behave the same. Okay, any questions about this? All right, so this is probably a pretty good time to take a break and stretch your legs. So how long does Tom give you? 5 minutes? That sounds good. So take 5, and we'll get back at 1:15. Yep.
The only reason why we're going to use an instant variable instead of a static variable is we're going to secure that whatever we're going to store, we're going to use only a variable or secure in this class only. So no one else from other classes will be.
Okay, that's about private.
Okay.
Private versus public, not static versus non-static. Instance, whatever.
Yeah, but then why we want to make sure this variable, this variable only accessible in this class only using instant?
Okay, why do we want it to be private?
Yeah.
Because if we make it private, we can control it.
Ah.
So you know in Python, so you asked about Python, so yeah. I gather you're a Python programmer. You know how in Python you put underscores in front of some. What does Python call them? They don't call them instance variables, do they?
No. I never heard about instant variables.
Yeah. Okay. I don't remember what Python calls them. But
yeah.
Anyway, you put an underscore in front of them. It's just a convention to say, don't touch this. This is mine.
Okay.
Nobody from outside should be reaching in and using it. So what Java does, unlike Python, is it lets you control it.
Sure.
It's not just a convention that says you shouldn't do this.
Actually, you won't be able to do it.
You can't do it.
Okay.
So think of private as being like putting the underscore in front, but you really mean it.
Sure. Okay. Thank you very much.
You're welcome.
Yeah, you raised a very interesting point. So what if we use private static over here?
Here,
Yes.
it would do exactly the same. Because there's only ever one object, right?
Yes.
In this use. So I could have made this more interesting by making it static.
And then, what are the dynamics that happen?
I'm not sure. So what dynamically what would happen if this said static is there would be an X and a Y that are sort of global to the whole program, basically. I mean, not global in the sense that they can be read from everywhere, because I made it private, so they can't. But they're basically it's lifetime, so they live for the entirety of the running of the program. So that's what happens first, and then we create this object here. I didn't write a constructor for that object, and I haven't even talked about constructors yet. So let's forget that part. So we get the object, and now we're going to just say m of 3. Apply or send that message to that object. So once again, y will be 3 here. We'll execute return x. X is still that same x. It just happens to be a class variable instead of an instance variable. Plus y, we still get this y, because that's the local one. Behaves exactly the same.
Like,
there isn't really any difference, because essentially this program ends after that, right? I mean, that's the end of main. That's the program exits after that. So 1 gets a value at the time the program starts, and it keeps the value until the program ends. Here, without the static, X and Y get values as soon as we do the new, which is the first thing we do. And those values go away when this object is no longer accessible. It gets garbage collected. I don't know if Tom has talked about garbage collection.
Why would be the instance variable in this case?
You mean
no, no. Y is a local variable. Well, Y is a parameter, which is a kind of local variable.
Okay.
But haven't been used in this program anywhere, right?
Which?
I mean why?
Oh, that Y.
Yeah.
Yes. No, you're right.
Not used at all.
It's not used at all. That's
Okay.
correct.
But in this coding, if I have another line saying system out print Y, which Y will go to? 3 or 2? 2. Okay. Because it's still within the class.
Because it's not in.
Oh.
Yeah. It's so. If you write that, that's a really good question. I should add that to it. That adds a lot of complexity to this. So what happens then is, no, I'm wrong. You get an error if you do that.
Oh, why?
Because it's not static. So,
okay.
So if you just say system.out.println, okay, the key thing is that you've said static here.
Oh.
Main is static.
Okay. Have to be over there, right?
That means main doesn't have an X and a Y. It doesn't have the instance variables.
All right.
So that's a really good question.
What if I have system out print over there? I mean, like above the main variable. No, main class over there. The system out print Y.
You mean in the method?
No, under the method between these two lines. Yeah.
You mean between, after that curly brace and before public?
Yeah.
You can't.
Like I can't do it, right?
No, you can't put code there.
Oh.
I mean, you can't put statements there.
Okay.
You can only put declarations.
Okay. Okay. Cool.
So you can declare more instance variables, more methods, but you can't run statements.
Okay. Sure. You're right.
If I change this public in time to private in time, the results won't change.
Which here, that private?
Private int m.
Yeah. So you change that to public int m. Is that what you're saying, or you're saying this public?
I change this public.
That public int to private. Yes, that would also work because we're within this message, within this class. Yes, exactly. That's what I meant to say.
Yeah. I think these are great. It would be great if we have more examples like this. Maybe post it online.
So doesn't Tom do these?
Yeah, we did, but
you haven't. So these aren't on the slides that you have online. Is that what you're saying?
No, we do have like one example of it, but there's so many interesting dynamics of it.
Oh, yeah.
So if you cover all of them.
Okay. Well, suggest that to Tom.
Okay.
No, I'm just doing this one lecture. So.
Sure.
Yeah. So yeah. But anyone ask Tom? Yep. No worries. Okay. Okay. So, as I said before, you want to make your accessors, I didn't say accessors. You want to make your instance variables private. You should always make your instance variables private. So if you make them private, how do you get to see them from outside the class? So you've got a person with a first name and a surname, and now you're holding that object, and maybe this is the main method, maybe this is some other method in some other class. You've got a hold of a person, you want to get the first name because you want to print a message to that person, address the person. So how do you do it? The answer is you write an accessor. So an accessor is a method. There's really, in a way, nothing special about it. It's just a particular style of method, a particular use, really, of a method. Which is, it's a method that takes no arguments and just returns some instance variable from a class. So that's called an accessor. It's also called a getter because it lets you get something. And also because, at least in Java, the convention, the standard operation, is to name the method get and then the name of the instance variable that you're trying to get. So if we have a person class, buried in that person class, we might well have a method that says public string get family name. So it's get family name, and it returns the family name. It's a trivial method. There's not a lot to it, and in fact, I don't know what IDE you guys are using, or what IDEs, but a lot of the IDEs will happily generate accessors for you, at the press of a button. You define an instance variable, and it will just make the accessors for you. It's perfectly well defined, right? It's going to be public because the purpose of the whole thing is to let another class get at this data. So it's going to be public. The return type of the method is always going to be the type of the instance variable, because that's what you're asking for. The name is always going to be get, followed by the instance variable name, except you have to capitalize the first letter, right? Camel case. And the body is always going to be return, and then the name of the instance variable. So it's perfectly unambiguously defined what an accessor should look like. So you might ask, well, why doesn't it just always do that? Why should it ask you whether or not you want to generate it? Shouldn't we just always do this? The answer is no. Definitely not. When you're designing the class, you need to think about which things it's legitimate for somebody to want access to and which things it's not. So it's probably reasonable to let somebody have access to a person's surname or first name. But maybe you decide that you don't want to give them access to the person's picture or whatever other information. Likely what's going to happen is you will have in that person class, in each person object, some information that's just for the purposes of your program. And it doesn't make sense for you to give access to that to some other part of the program. The thing is, what it costs you to give access to something, what it costs you is essentially it ties your hands. Once you've done this, public string get first name or get family name, you have to have that method, right? If you decide, oh, maybe we don't want to have a family name. In this case, it's probably not going to happen. But in many cases, you design a class, you decide what the instance variables should be, but you always want to keep as much flexibility for yourself as the developer of the class as you can. And once you've made a method public, you're kind of promising other people that are developing parts of this application that that's going to stay there, that you're going to continue to support that into the future. Once you've done that, you're sort of committed. You may later decide that, yeah, this family name, first name, that's a mess. You know, when Frankie comes in, he doesn't even know his surname, or maybe his surname is Jones and everybody calls him Jonesy. He doesn't even remember what his first name is. So you just want to say it's a name. But you've gone and done this, get family name. So what are you going to do? You can't change that now. You've tied your hands. So you want to think about what is the functionality you want each class to have. What are you confident you will need, you will want to allow to be done to this object into the future, into the indefinite future? Those are the things you want to make public. Other things, you want to be circumspect. You don't want to promise too much. Better to under-promise and over-deliver than over-promise and under-deliver. Okay, so that's accessors. As I said, really simple, but don't always just create an accessor for everything. And that goes double for mutators when you come to them next week. Okay, so constructors. Now, we've got a class. It has some instance variables. The question is, how do the instance variables get initialized? How do they get values in the first place? So you go to create a person, you know that their first name should be this and their surname should be that. How do you create a person that has this first name and that, given name and family name? How do you create a person that has those things in it? Particularly when you've gone and you've made the given name and family name private. So now you can't change them from outside the class. Well, the answer is you give them values when you first create the object. And that's the role of the constructor. So what the constructor is it's a special method. It's not really a method. Because the thing about methods is it's code that gets executed by sending a message to an object. A constructor is special because it gets called when the object is first being created. The object doesn't even exist to send it any messages. So it's special and it's wired into this the new construct in Java. So when you say new, no, I don't have one on the screen. When you say new person, what that's going to do is it's going to allocate enough memory to store a person, and then it's going to execute the constructor. And if it can't allocate enough memory, that is possible but doesn't happen often, then it won't execute the constructor. Basically, your program's going to abort then. But so the idea of a constructor is, as I said, it's like a method, but it's not a method. So the syntax for declaring it is just a little bit different. For one thing, the constructor never returns anything. It doesn't return the object just constructed. That's part of the new. New does that for you. All it does is initialize all the instance variables. Okay, so the syntax is, well, usually you say public, but you can say private, and that is a meaningful thing to do, and sometimes it's the right thing to do. So once again, it comes down to deciding carefully which things you want other people to be able to use. But often it's going to be public. So we'll just, for the moment, let's just declare it public. And then notice that there's no return type at all. We just say public and the class name. So the constructor's method name, if you will, is always the name of the class. Special case. Always has to be exactly the name of the class. And then it can take parameters, and that's really the point of the whole thing. So when you say new person, open paren, first name, surname, then that will execute this. Well, first it will, as I said, first it will allocate the memory, and then it will invoke this method, person, and have those two parameters. Okay. So here's an example. Public person, string F, string G, and now we can say family name equals F, given name equals G. This would be a pretty typical sort of constructor. It takes one parameter for each of the instance variables. It initializes the instance variable from the parameter. And so now we can say person king equals new person Snow, comma John. Yeah, it's a little out of date, but anyway. So what this will do is it will allocate enough memory for a person, and then it will invoke this method, this pseudo method constructor, and F will be, I did it backwards. Oh no, I didn't. F is a family name. So the family name is Snow, and the given name is John, and then it will do this: family name equals Snow, given name equals John. It initializes it. Notice it doesn't return anything. You never return anything from a constructor, and that's it. So now what that means is king is going to be an object that has been allocated, has enough memory for it, and has had these operations performed on it. So in other words, the instance variables are initialized. Now, what is important is that when you say new, like this, and the class name, notice that the class of the variable, or the type of the variable you're initializing is always the same as the class or the constructor. So this is both the constructor and the class that's being constructed. So it will always call the constructor with the right number and types of arguments. In this case, we have 2 string arguments, and that matches that one. So if you have constructors with the wrong number of arguments, but none with the right number of arguments for the call you're making, that's an error. The compiler will refuse to compile that program. And there's one little special thing that the Java compiler does for you is if you don't write any constructors at all for a class, Java will automatically create for you a constructor that takes no arguments and does nothing at all. And that's why that works. Notice no constructors. And here I still say new QP0501. That works because Java has automatically created a constructor for us that takes no arguments. But here's the interesting thing. If we go back to this guy, so this is living inside the person class, and we've given it a constructor with 2 arguments. So what's going to happen if I say new person, open paren, close paren? Some other class. I say person P equals new person, open paren, close paren. What's going to happen? Kind of nothing, but a particular kind of nothing. Yeah, you get a compiler error. Because in order for that to work, you have to have a constructor with no arguments. And as I said, if you write a class with no constructor at all, you automatically get for free a constructor with no arguments. But we have given it a constructor right there. And it took 2 arguments. So it doesn't give us that free constructor with no arguments. And therefore, this class, this person class, has no constructor with no arguments. Okay, so that would be an error. Okay, so inside your constructor, you're going to want to do a few kinds of things, but typically what you want to do is assign your instance variables. That's basically the job of a constructor, is to initialize the instance variables. Now, some of them you'll initialize from parameters in the constructor method. Others you might initialize to default values, or you compute something from somewhere, whatever. But typically, you're going to be initializing them from parameters, or else defaults. Now, to refer to a instance variable, we can do it as we've been doing it. We can just use the name, so as we did here. So family name equals, so that refers to the family name instance variable. But remember the rule, if you have an instance variable and a local variable, both with the same name, you get the local variable. You don't get the instance variable. So that's why I've called this F. The kind of natural thing to call it would be family name, wouldn't it? But if I called it family name, then this would say family name equals family name, which kind of sounds like nonsense, doesn't it? It wouldn't work. It would just be reassigning the family name local variable to the value it already has. So we'd like to have a way to say inside a method to get to the object, to get to the instance variables of the object that is executing the method. And there is a way to do that. So what we can say is object.name, where name is the name of an instance variable. Remember, that's essentially what we've been doing to send a message to something. We say object.messageName. Well, we do the same thing to get at the instance variables of an object. We say object.instanceVariableName. Okay. Now, in order to access the instance variable, in order to be able to refer to it at all, it has to be visible to that line of code where we're trying to refer to it. If we make it private, that means it's visible only inside that class. So if we have an instance of a person, let's call it P, and we want to get at the person's given name, inside the person class, we can say p.givenname. That will work just fine. Outside of the person class, it's private. We can't say p.givenname. But inside the class, we can do it. Okay. Right. All right. So now, let's say we're talking about the constructor for the class. How do we refer to the object that is now being constructed? It wasn't one of the parameters, right? The parameters to the constructor are just extra things. It's the object that is being constructed is not a parameter to that method, so to that constructor method. So how do we access it? The answer is Java has a special syntax that lets you refer to it. And that is through the word this. So this kind of acts like it's a variable. It's a special variable you didn't have to initialize. And in any instance method, it's the object that you sent the message to. And that includes in a constructor. So what we can do, the nicer name for the arguments to this person, or the parameters to this person method or constructor, are string given name and string family name. Now we can do that because here we can say this dot given name equals given name, and this dot family name equals family name. And notice these two things refer to completely different things. When we say this dot given name, it refers to the instance variable in the person class. When we say given name by itself, that refers to the local variable, to the parameter. Okay? So this is actually the typical way that people write constructors. Constructors. You'll see that it's very common. I believe the IDEs will generate this sort of thing for you too. All right, so at the beginning of the lecture we talked about null. Null is a special value that's not really an object but kind of acts like one, and essentially null is a thing that you can pass for any class of object. Or you can store it in a variable of any class, or an instance variable of any class. But not, by the way, in a instance variable or a variable of primitive type. So you can't say int x equal null. All right, that's not allowed. But in any reference to an object, you can pass it or store it. So, so what happens if you do that and you try to send it a message? So you say p equals null, and then you say a little later p dot get full name. Bang is what happens. Your program crashes. You'll get an exception. Okay. Now you can actually catch these and make your program do something more sensible than just print that. But you shouldn't. What you should do instead is check. You're kind of obliged to check whenever you send a message to an object to make sure that it's actually an object and not null. So if you forget to check, expect to start seeing this. And I'd be surprised if more than a few % of you don't see this message by the time you're done with this class. It just happens all the time. It's a pitfall that we all have to trip into a few times. Basically, as I said, you're obliged to check before you send a message to an object to see whether or not it's null. On the other hand, if you've checked, you've got an object P. Now you say, you know, if P not equal, well, actually, maybe what you say is if P equal null, P equal null, then, I don't know, print an error message and terminate the program, or I don't know, maybe you've got, whatever it is you're going to do, you do that. And then after that, you've checked it. You know P is not null until you reassign P to some other, assign some other value to P, it's going to still be not null. So you don't have to keep checking it over and over, but you have to check everything once. Okay. All right, so one of the, if you notice, the title of this lecture is about immutable classes and immutable objects. So the concept of an immutable object is it's just an object that can't be changed. So you've already seen a kind of object that can't be changed. Do you know what it is? I think somebody said it. String, right. You can't change a string. You can create a string object. You can concatenate two strings together, but the two strings that you concatenated together are still the same strings they were before. You just get a new string out. There's nothing you can do to a string to make it be a different string. And that's the idea of an immutable object. If a person object is immutable, it means once you get the person object, it can't be changed to any other person object. Okay, and one of the standard bits of advice you'll read if you read some of the programming blogs and standard advice to programmers is make your objects, make your classes immutable as often as possible. If at all possible, you should make it immutable. Because essentially you save yourself a whole bunch of nightmares, a whole bunch of problems that can happen. So that's the standard advice. So next week you'll learn how to not follow that advice. But for today, let's all follow that advice. So if you have a class of which every instance is immutable, then we say that the whole class is immutable. And typically that's what happens, right? It's hard to make one instance immutable, but another instance of the same class not immutable. That's kind of difficult. So typically, if any instance is immutable, the whole class is immutable. And it's actually quite easy to make a class immutable. You simply provide no method that lets you change it. Okay, so if you had say a given name and a given name and a family name in a person class, if you provide no method that will change the first name or change the given name or change the surname, then that class is immutable. And that's that's one of the points of making these things private. If you make the instance variables public, you can't make it immutable. Anybody who gets a hold of a person can change it all they want. They can change it to complete nonsense. They can store null in the first name and null in the surname. Whatever they want to do, they can do it. But once you make it private, and then you make the only public methods for the class just don't mutate the class, mutate the instance variables of the class, then you have an immutable class. So string is immutable. All the primitive types are immutable, sort of by definition. It doesn't make sense. I mean, if you think about it, what would it mean to not be the case? What if I have a method and I pass it 42? I have a variable p, and it holds 42. And I pass p to a method. And then the method returns, and I come back, and now I print p, and it's 50. It's just bizarre. It's a bizarre concept to think a number has changed. Actually, in the earliest days of Fortran, the very first Fortran compilers, you could actually do that. You could modify a number, and then thereafter, anytime you use that number in that program, it would be a different number. Imagine, that would be horrible. So anyway, immutable is a good idea. Okay, so Java can actually help you with this. So you decide you're going to make the person class immutable. Now, all you have to do is make sure that none of the methods in the person class actually change its instance variables. That's kind of a pain. I mean, what happens if your person class is, 20 pages of code? Imagine trying to check 20 pages of code to make sure that nobody mutates any of the instance variables. That's hard. But Java gives you a nice little tool, and that's the word final. So you've seen that before for constants. You can make an instance variable final. And what that means is the constructor is allowed to give a value to that instance variable only once. It's not allowed to, once it assigns it, it's not allowed to assign it again. And nothing outside the constructor is allowed to assign it. So if we declared family name and given name to be private final, That's it. It's immutable. All of its instance variables cannot be changed. Well, at least they can't be changed outside of the constructor, and they can only be changed once in the constructor. So that's it. And now it's safe. It's immutable. So if you accidentally do something like this, you're writing some method, and you probably wouldn't call it bogus. You'd call it really important method that it does exactly what I want, and then you make it not do what you want. So you say this dot family name equals s. The Java compiler will do this for you. Error. Cannot assign a value to a final variable family name. And it points you to what line? Yep, line 12, right there. This dot family name. So one really nice thing about Java is when it gets an error message like this, it tells you where your bug is, right? Anyway, that can save you a lot of grief. Makes it very easy to fix it. Okay, so here's one pitfall, and we were sort of going over this earlier. There's a difference between instance variables and class variables, and a difference between instance methods and class methods. And it's really important to have this distinction down pretty well. The key difference is a class method, well, back up, take the first thing first. A class variable, there's only one. You can make as many instances as you want of the class, but there's only one copy of that instance variable. That can be handy. It can be quite useful to do that, but it's not usually what you want. You usually want the data to be per object. And now instance methods versus class methods. The important distinction to remember is that with a class method, there is no object. So what it really comes down to is there's no such thing as this in a class method. So you can't access instance variables because this dot family name, this dot given name don't exist. There just is no such thing. So you can't access them. What you can do in a static method, like main, for example, is you can create an object and you can send it messages. You can send it instance messages, because then you're providing the object to send that message to. But in a static method, if you just call a method directly without specifying an object to send the message to, it must be a class method. Okay. So there's there's a number of special methods in a class, but one in particular is the toString method. It's quite handy because the Java system makes use of it. So if you define it yourself, you're essentially hooking into the Java system to tell it how to do things. So what the toString method does is it tells you how you want to display an instance of that type. So toString is an instance method, and it says if you have an instance and you call toString on that, this is what I want to appear. And the way it works is it returns a string. And then whether that string is going to be written out to a file or written out to the console or passed around the program and then something else happens to it, I don't know, maybe it prints it on the screen. whatever it's going to do with it, the string tells you how to display a thing like that. So, so if you want to, so in the case of the person class, a sensible way to display a person is as first name, or given name, family name. So that's what we'll do. Public string to string. So it returns a string. It doesn't take any parameters. Essentially it works on this. It's got that hidden parameter this, and that's all. And so all we have to do is return given name plus a space plus family name. And then once we've done that, then in several places in Java where it needs to essentially turn an object into a string, or provide a string pronunciation, if you like, of an object, that's what it will do. I thought I had an example. Yeah, here it is. So if I say system.out.print p, and p is a person object, or if I just say welcome, the string welcome plus p, then what Java wants to do is sort of turn that object into a string so that it can concatenate it. And you'll recall that's what happens if you said, well, you wouldn't say welcome, but, the answer is colon, and then in quotes, and then plus x, where x is an integer. It's going to do the same kind of thing. It turns that integer into a string for you. Well, so that's what's going to happen to an object as well. So if we say system.out.print p, or if we say welcome in a string, welcome plus p, it will call this toString method here. Okay. All right, so wrapping up what we've seen today, we say new and then a class name and then in parens some arguments in order to construct a new object. And the arguments need to match up with a constructor. The number and type of arguments need to match up with one of the constructors for the class. And we say object.method name, and again, some arguments in parentheses. And again, the number and types of arguments have to match up with a method for the class, and that will invoke one of the methods in the class. We've got this special thing called null, which is kind of think of it as an honorary or maybe a dishonorary member of all classes. It's not really an object, but you can use it wherever there is an object. But if you try to send it a message, bang. So don't do that. So that means you need to check before you send a message to an object, because it could be null. So you declare instance variables in a class in the same way that you declare class variables in the class, except you don't say static. And that means every instance of that class has a separate value, a distinct value for that variable. Good practice, best practice, is to always make instance variables private. You shouldn't make them public. You should write a constructor for each class to initialize all its instance variables. And particularly if you go with the idea on the last point, bullet point, of making your classes immutable, then basically you got one chance to provide data, to store data in your object, and that is in the constructor. So you should write a constructor that provides enough information to the constructor to initialize all the variables the way you want them. And then, as I say, You should make your classes immutable if at all possible. All right, and that will wrap us up for today. And Tom will be back with you next, what is today? Monday. Next Monday.